Okay, can. Then I will start with the previous lesson first because we need some of the formulas from the previous lesson. So I will start to go through. Okay, so the previous lesson actually is going to be on mole and concentration, but I'm not going to focus that much on concentration for today. So that one, 如果你有时间, if you have time, go and watch the videos if you can. Yeah, I will suggest that. Okay. So the learning objectives for this part is basically just to define what exactly is mole. Okay. And then basically use this idea to do calculations. Okay. So the mole, right, is basically like a collective term. It's like a group like that. Because you know that when we talk about like the compounds, all those particles, let's say it's atoms or molecules, right? They're all so small. It doesn't make sense for me to say, like, for example, my small water bottle here, oh, the amount of water inside is 400 million billion, don't know how many water molecules lah. Yeah, it will take forever to say. So we create this grouping system known as the mole, okay, to describe how many particles there are. So one mole 到底是什么? What exactly is it? One mole of anything contains this number of particles. So it's quite big. Just for your visualization of how big the number is, right? 10 power 23. If you take E-math and you have learned indices, this means that there are 23 zeros after this number. That's how big this one mole is. Okay, so it scales it down to something that we can visualize better. Okay, and this person that came up with this magic number, right, is this guy called Avogadro. So therefore, this one is called as Avogadro's constant. Okay, not avocado. Okay, so with this, right, we introduce a first triangle. Triangles in this chapter, right, actually they help us to remember the formula better. I don't know for you, but for me, I feel that it helps. Okay, so if let's say I want to find out how many mole, let's say I have 6.02 times 10 to the power of 23 chlorine atoms. So how many mole is this? So using the triangle here, okay, if you want to find mole, you need to do number of particles divide by this Avogadro constant. Okay, because it's one on top of another. Okay, so mole equals to particles over 6.02 times 10 to the power of 23. Okay, so if you want to find how many moles there are, it's like one group like that. How many groups are? You just take the number of particles, which I give you here, and then over the Avogadro constant, which means just nice, this one is one mole only. Okay, so the unit, right, is mol for mole. Okay, so as long as you have this number of particles, it's one mole. That's how you use this triangle. Okay. So for example, if I tell you I have one mole of calcium atoms, means I have this number of calcium atoms, okay, which is about 40 grams. And then one mole of NH3 molecules is exactly this number. Okay, so it's always this number that keeps coming up. Okay. And must memorize this number one. Yeah, next time when your school teach, they will tell you that you need to memorize also. So example questions that they can test on this type will be things like, oh, how many atoms are there in 2 moles of H2SO4? So H2SO4, they're referring to 2 moles, 2 groups. You can think of it as 2 groups. Okay, 2 groups of H2SO4. Okay, so remember our triangle? Okay, so the triangle was particles, oops, particles, mole, and then the 6.02 times 10 to the power 23. Okay, now I have mole. I want to find number of atoms. So I'm trying to find number of particles instead. So triangle states that number of particles means I take number of mole times the Avogadro constant. Since they're on the same level, means you multiply. Okay, so 2 moles means I need to multiply the mole, which is 2, times the Avogadro constant here, which is here. Okay, so if I go and type into calculator, you can go and calculate, you will get 12.04 times 10 to the 23 H2SO4 molecules. This is how I find the particles. Okay, but then this one doesn't really answer the question because question asks how many atoms are there. Molecule is like, oh, like one H2SO4 is maybe this is the SO4, then the H2 is like that. Like that. This is one particle. But I want to find how many atoms. So inside one H2SO4, there are two H atoms, one S atom, and four O atoms. So basically, if I take this molecule, right, and then I go and dissect it, I will get seven different atoms. Every one molecule, I get seven atoms. Two become 14, three become 21. Basically, need to times seven. Okay, so the number of atoms in 2 moles is basically 7 times the number of molecules here that you calculated, which is this 12.04 times 10 to the 23. Then everything punch calculator. Okay, you will get this. Okay, the rest is all extra one. This one I will skip lah. Okay, Okay, then the second one is about mass and molar mass. So the question comes why this guy go and choose this particular value, what the 6.02 times 10 to the 23 lah. Okay, so let's take a look at your periodic table. Okay, so why he chose that number, right, was because of this reason. Do you see that the carbon relative atomic mass, so relative atomic mass of carbon is 12. This one is in your periodic table. It's the mass number. Okay. So basically, this guy started wondering in 12 grams, because this one is relative atomic mass, what about 12 grams, specific amount of mass? How many carbon atoms together will give me 12 grams? And then he found out that actually this was the 6.02 times 10 to the 23. That's how the number came about. Okay, so 12, every 12 grams of carbon means there's 1 mole. 1 mole of carbon. Okay, okay. So basically here is just to bring the idea over to you. You realize 1 mole of carbon, oops. So 1 mole of carbon is 12 grams. So think of mole as group. If I have 2 moles, it will be 24 grams. If I have 10 moles, this will be 120 grams. So basically you realize okay, mole multiplied by the relative molecular mass on the periodic table, okay, which is known as the molar mass now. Molar mass, okay, which is MR, will give you the mass. This is the trend here, number of mole times the molar mass will give you the actual mass. Okay, so that's why we come up with this whole triangle again. Mass equals to mole times MR. Okay, and okay, so example here, I ask you, what is the mass of 1.5 mole of water? So always remember the triangle will be mass on top, then this is mole, and this is MR. And MR, find from periodic table. Okay, you can get it from the periodic table. Periodic table. Okay, so I want the mass of 1.5 mole of H2O. So first, maybe I need to find out what is the MR of H2O lah. Okay. MR of H2O basically is the total mass of 2 hydrogen and 1 oxygen, because water is 2 hydrogen and 1 oxygen. Okay, so hydrogen, the mass is 1, right? I need to multiply by 2, and then I have a 16 from the oxygen. So total MR for one water molecule is 18. Okay, then mass equals to MR times mole, as you can see from the formula here. So I take the MR, which is 18. Okay, and then how many mole do I have? I got 1.5 mole. So bring it down here. Then just multiply them, you get 27. So 1.5 mole of water weighs 27 grams. Okay, that's my final answer for this. Okay, so that's how we use this triangle also. Okay, it links the concept of mole to mass. Okay. Okay, so I skip. Then I need to go through molar volume of gases also. So molar volume of gases, right, basically tells you that if you have 1 mole of any gas, 1 mole of any gas, this gas can be whatever hydrogen gas oxygen gas carbon dioxide nitrogen, ammonia, whatever. Okay, clearly they all have different mass. 1 mole of them have different mass because their MR all different. But what is interesting about gases is that they all occupy the same volume. as long as you have the same number of mole. Okay, so it doesn't matter whether you're a small gas or a big gas, as long as you have 1 mole, you will always occupy 24 dm cube volume worth of space. Okay, and then dm cube basically is just for you to know, dm cube is the same thing as liters. Okay, so that's for you to compare and contrast. Okay, and very specific, this one, right, only occurs at room temperature and pressure. Okay, because the moment I change temperature, like I increase the temperature, my gas can expand. Then it wouldn't be 24 anymore already. So it's fixed, must be room temperature or 25 degrees Celsius. Okay, and then room pressure at room pressure also. So you don't purposely go and squeeze the air. You squeeze the air, then you occupy less volume. So okay, so this one will be 1 atmospheric pressure, our usual pressure around us. Okay, which means if I let's say I have 1 mole of nitrogen gas for example, okay, confirm this one will occupy 24 dm cube. If I have 2 moles of nitrogen, this will occupy 48 dm cube. Every one group 1 mole will occupy 24. Okay, so that's how I come about with our third triangle. If you want to find the total volume occupied by the gas, okay, you find the number of mole of gas you have. Then you go and times 24 Okay. So example here, what is the volume occupied when you have 3 moles of sulfur dioxide gas? Okay, so you know that this is a gas, you must think of the molar volume of gases, that triangle. Okay, so I draw here at the bottom. Okay, here is volume, this is 24, this one is mole. So I want to find out what is the volume. I must take mole times 24, since this is a gas. Okay, so simply just use the formula mole times 24. Okay, so number of mole is 3 I got 3 groups, 3 moles. 3 times 24, I get 72. Then make sure that your units is correct, not cm cube. This one must be dm cube. In chemistry, try not to write liters also just write dm cube. Okay. Another example, maybe you take a look at this. How many moles of HCl gas is present in the volume of 20 dm cube? So I got 20 dm cube of this hydrogen chloride gas. Then they ask you how many moles is that. So if I want to find mole, I need to take volume divided by 24 according to the triangle. Okay, so I take the volume here, which is 20, divide by 24. I get the number of mole. So 0.833 if I round off to 3sm. This number of mole of HCl will occupy 20 dm cube of volume. Okay. Okay, so I'll skip. Okay, then concentrations I will skip also because we won't need that for today's practice questions. Okay, so that one is basically to give you the background of mole and then a little bit of a calculation. Then I go into the lesson for today proper. Okay, chapter 12. Okay, so the first thing for us to learn is this thing known as empirical formula. So what exactly is empirical formula? Okay, empirical formula basically shows you the simplest ratio of the atoms in a substance. It must be simplest ratio. It does not necessarily mean it is the actual molecular formula. It's just the simplest ratio. Okay. So for example, I have this compound here called ethanoic acid. Sometimes people very fancy, they write it like this, CH3COOH. Okay, but you can actually condense it. You can see got 2 carbon, so C2. Then you have 4 hydrogen, because there's 3 here and 1 here. So H4, and then 2 oxygen here, so O2. This is the actual molecular formula of the compound. But then you realize everything, like the C2H4O2, right, everything is like even number. So what is the simplest form that I can express this? Empirical formula will be CH2O, everything divided by 2. Okay, so it is the simplest ratio. Okay, it doesn't represent the actual formula, it's just the simplest ratio. Okay, and you can actually find out information about a compound. You can determine the empirical formula if you have certain information. For example, percentage composition of the compound. So later we'll go through some examples and see what they look like. Okay, so for example, we know that an unknown compound was found to have the following composition. So you don't know what is this compound. You don't even know what is its formula, but you know that it contains calcium, sulfur, and oxygen. Then the question asks you, can you go and find what is the empirical formula? So